So we're still in the intro notes in worksheet 1. Told you it'd be several videos. I think we're on the 4th video now. So now we're moving on and we're actually in worksheet 1. And so in worksheet 1, we're given a position time graph. So I'm going to work these first two and then I'm going to let you all kind of do the next two on your own and then we'll see where we go. So, all right, problem 1, we're given this position time graph. Now, I see here that it looks like we're going to be traveling for about 7 seconds here. And I'm going to assume nothing happens on this 8th second. We'll kind of talk about that. So this object, where does it start? I look at 0 seconds. It's starting at 0 meters. So I'm going to draw a dot at 0 meters because that's where it starts. And I'm going to see just how far it's going in 1 second. So in 1 second, for 1 second, I travel up 2 meters. So I have this graph. They actually put 5 meters here. That means every hash mark is a meter. It might be good to clarify that. So I'm going to draw this object here. So this dot starts at 0 and it goes 2 meters in 1 second. And it actually looks like if I do the same math again, I go 2 meters in 1 second again. So I'm going to do the same thing and I'll end at 4 meters, which is what I'm expecting. So this is my first 2 seconds. When you see a flat line on position time graph, what it's saying is I start at 4 meters, I end at 4 meters. So that is just a naked dot. There's no arrow on it, it's just there. And now for the next 4 seconds, it looks like I go down a meter, and that's a negative 1 meter. When you go down, it's negative. When you go up, it's positive, unless you clarify it's not that. Go over for 1 second. So negative 1 meters per second for the next 4 seconds. And there we go. When I make a dot on a motion map, you always start with the dot and then you draw the arrow. So it's always dot and then you draw whatever direction these arrows are supposed to go. So you draw the dot, you make the arrow. There should not be a final dot. The only way you can justify there is a final dot is if you're saying it stays still for 1 second and you put a dot there. I don't think they actually meant it stays still for a second, so I'm not putting the dot there. So I'm not putting a final dot. There should be 7 dots. 1, 2, 3, 4, 5, 6, 7. That looks like 7 dots. Looks good to me. And I want to clarify start and finish. This graph, it can only work one way really, but I really want to clarify what it's doing. Actually, it could work 2 ways, but I won't go into that. All right, let's describe the motion of the object in words. This object travels forward at 2 meters per second for 2 seconds, stops for 1 second, and travels backwards at negative 1 meters per second for 4 seconds. Now, very dry explanation. I find that these dry explanations are better than more superfluous ones because it gets kind of confusing if you're adding in other things, it'll get complicated. Just make it as simple as possible. So that's my description. Hopefully you're kind of good with this. We're going to have another problem. This time, instead of starting with the position time graph, we're given the motion map. So I'll work it out in a second. Let's see if you can try to make what this is first. If you do it first and then see what I do, I think you'll be better off for it. So I'm going to pause the video and give you a chance to do this one. All right, so hopefully y'all had some time. I actually even wrote out the description here. Very dry again. Object moves backwards at negative 1 meters per second for 3 seconds, stops for 2, moves backwards at negative 1 meters per second for 2 seconds, stops for 2 seconds again, and moves forward at 2 meters per second for 3 seconds. Now, one thing I did not put in here, and I'm actually going to add it, object starts at 5 meters, and now it's destroyed my formatting. But the object starts at 5 meters. That's pretty important to clarify because if I hadn't seen that, I would have started this graph at 0 and then moved backwards into the negative. So anyways, that's what's happening there. let's make that motion map. So I'm starting at the 5 meter mark, and I'm just gonna go 1 second at a time. So this object, the dot is here, it's at 5 meters, and the next dot's at 4. So I can draw this object, and it's really just doing that. And it actually does that 3 or 2 more times for a total of 3 seconds. So once you find out 1 second and you see it keeps moving that way, you can do the rest of the seconds until you know when it stops moving that way. You can just like shortcut it and go straight across. It stops for 2, so it's at 2 meters for 2 seconds. That's what it would look like. It goes backwards for 2. We stop for 2. And then, all right, so this is a new motion. We're going forward now, and it goes, starts at 0, and the next one's at 2, and the next one's at 4. So we're going at 2 meters per second for 3 seconds. Now, what's interesting here is this dot, it starts at 4, and we're gonna end at like 6 meters. So if I like expanded the graph up here, kind of a weird graph, but we're gonna end at 6 meters. And just to clarify, for when you're doing this on OneNote, what I would do is just get your ruler out. You can line up the exact slope, and we can actually get an actual number of what it should be. So 1, 2, now I need to get up to probably around 6 is there. So I would say 6 is here, 6 meters up there. So that's my graph. It goes a little bit off because of how they gave it to us, but that's what it is. So I want y'all to work these next problems out, and I'll go over them. So I'll give you guys a couple seconds or a couple minutes, pause the video, and then we'll go for. All right, hopefully you've had some time to work on this. So you got this position time graph. We've actually seen this graph before up in the motion map reading. The one thing is that, and it was a different time, but A was actually the slower one, B was the faster one. In this case, you can see here that A has the steeper slope, B is the slower slope, or the less steep slope. But let's just start answering these questions. Do the cyclists start at the same point? How do you know? They do not. B is higher up than A, and I can see that literally on this position time graph. B is literally higher than A on the graph. So let's say B's at like 2 meters, A's at 0 meters. So no, B is ahead. At 7 seconds, which cyclist is ahead? Well, after 5, A is always higher up on this graph than B. So I know A is ahead anytime after 5 seconds. So, sorry about that. So part C, which cyclist is traveling faster at 3 seconds? How do you know? So what we'll learn, and we'll have a lot more examples on this, the steeper the slope, steeper slope means a greater velocity. So it means a greater velocity. Because A, the entire time, they both have the same slope. If A's slope is 5 meters per second and B's is 3 meters per second, that is just that is the slope value, that is their velocity value the entire time. So which cyclist is traveling faster at 3 seconds? It's A. Then they ask, are their velocities equal at any time? Some kids will say, oh, maybe at this position they are. No, they're not. What the lines actually represent, like where they are, is their position. The slope of it determines velocity. A at this intersection just always has a steeper slope. So A has the faster velocity. What's happening at the intersections? That is just where they're passing each other. So they start to pass each other. At that moment in time, they are at the same position. And then let's draw a motion map. I'll say that, it looks like it's about 10 seconds. So with motion maps, you can actually clarify that a dot is not 1 second. If I don't see any clarification, I'm going to assume it's 1 second. I'll make this one 2 seconds. And the reason why I'm doing 2 seconds is that I don't want to draw 20 dots. I want to just draw as little as I have to, while also keeping the meaning of it. So when I draw this, basically what I'm going to do is A is going to start at the origin. So the first arrow for A will look like this. And then B is going to start not on the origin. And you'll notice that B is a shorter arrow. A's is like a hash mark and a half. B's is just 1. So I'm going to pause the video and I will show the completed one in a second. All right, this is my completed motion map. Not the prettiest one, but you can see here by the end, A gets ahead of B, which is what actually happens. When there's no numbers, I wouldn't focus too much on like making it exact. The only thing you have to be exact about is the amount of seconds. There are 5 dots for B, so that's 10 seconds. 5 dots for A, that's also 10 seconds. So good. Now let's work on this one. I'll give you guys a second to work on this, and then we'll get back together. All right, so hopefully you've done it. Please work on this before I go over it. But the difference in A, so they give us the previous graph, so we have an easy reference compared to the new. A is going the same speed, so same speed. But different direction, negative direction, opposite direction. So I'll just put opposite direction. B is the same. Which cyclist has the greater speed? So this is an interesting question. Speed, first off, does not have positive or negative signs to it. It's just what the value actually is. Even though A is moving in the negative direction, it still has a steeper slope. So A, and I'm just going to put steeper slope. Now what's happening at the intersection, they're at the same position. They're passing each other. Something along those lines. They ask us which cyclist traveled further during the first 5 seconds. Now, using logic, and logic's a very specific skill in physics. It doesn't necessarily mean smarter or dumber or anything. Logic is just, if this is true, then something else may or may not be true. If I look at this object, after 5 seconds, cyclist A has moved this far down. Cyclist B has moved this far up. I mean, I could see here that A has gone like a further distance just judging by that arrow in the same time span for both of these cyclists, right? Green is the time span. So they both share the same time span. A is going faster. If you just think of, someone's running really fast for 5 seconds and someone's walking for 5 seconds, the one running fast will go further. So A has gone further. A has gone further. And I'll just say more vertical change in the graph. Draw a motion map. All right, I'm just going to draw it really quick. The big difference between the last one and this one is B still like starts kind of ahead. B's going to look like this. And I'll just redraw B the same way. A is just going to start way out here, though. And hopefully, it looks like I kind of drew it too big again. But A is over here. At some point in the middle, they're going to pass each other. It's harder to tell on this motion map, but that's what we got. All right, thank you, guys. We're going to work on worksheet 2 next, so head over there.